Hi, welcome back to my channel. My name is Gina. Last week, we looked at Newton's first and second laws and different types of forces. If you haven't watched the video, I'll put the link up there. Today, we are going to look at two examples using Newton's second law. The first one, suppose your car ran out of gas and the mass of your car is 2,000 kilograms. Then a tow truck is pulling your car with a force 5,000 newtons with an angle 30 degrees above the horizontal. And you are pushing the car from the back with a force 2,000 newtons, and the force is parallel to the ground. We want to find the acceleration of the car if the friction is negligible. Let's start with drawing the force diagram. So suppose you are bringing from the side. This is your car. What are the forces acting on the car? There is always the gravity force that is pointing downward. And the car is on the ground, so there is the normal force that is pointing upward. And from the question, we know that the tow truck is pulling the car with a force of 5,000 newtons with an angle 30 degrees above the horizontal. And let's call this force of pull. And this has magnitude 5,000 newtons. And the angle here is 30 degrees. Furthermore, you are pushing the car from the back with a force of 2,000 newtons. And let's call this force of push. And it has magnitude of 2,000 newtons. Now we want to find the acceleration of the car. Let's use Newton's second law. And similarly with the kinetic problems in two dimensions, we can look at the x and the y components separately because they are independent. Here we are going to use the conventional coordinate, which is x is positive to the right and y is positive upward. In part A, let's use Newton's second law in the x direction. So F net in x equals to mass times acceleration in x. So what are the forces in the x direction? There is the force of push from the back. There is also x component of the F of pull. And both of them are pointing to the positive direction. So F net in x would be F pull in x plus force of push. And this equals to mass times acceleration in x. Force of pull in x direction, using some geometry, it equals to the magnitude, which is 5,000 newtons, times cosine of theta, and theta here is 30 degrees, and plus force of push, 2,000 newtons. And this equals to the mass of the object, which is 2,000 kilograms, times the acceleration in x. Now let's isolate for the acceleration. It equals to 5,000 times cosine of 30 plus 2,000, and whole thing divided by 2,000. You plug the numbers in your calculator to find that acceleration in x is 3.16 and the unit is meter per second squared. And since there's no acceleration in y, because there's no movement in the y direction, the car will still stay on the ground. It will not move up and down. So the acceleration is 3.16 times I hat plus 0 times j hat meter per second squared. Now let's look at a second example. A box of 10 kilograms is resting on the table. A rope is tied to the box and it runs vertically upward over a pulley, and the mass is attached to the other end of the rod. We want to find the force that the table exerts on the box if the mass hanging on the other side of the pulley is 2 kilograms and 5 kilograms. Let's start with drawing the forces on the diagram. So for the 10 kilogram mass, there is gravity force that is pointing downward. And the normal force exerted by the table, which is the force that we want to find. And since the box is attached to a rod, so there is a tension force that is pointing toward the rod. Now let's look at the mass at the other end. There is also the gravity force. Let's call that Fg2. And the mass is also attached to the same rod, and assume that the rod doesn't stretch. So this tension force has the same magnitude as the tension force acting on the other mass, Ft. Let's call the mass on the other side N2. Now let's look at Newton's second law on mass 1 and mass 2. Let's start with mass 2. In this problem, there are only forces in the y direction. Let's define y is positive upward. So Newton's second law says F net equals to mass times acceleration. And since we want to find the normal force, which means the object on the bottom is always in contact with the ground, so the acceleration would be 0. And the net force is tension force minus the gravity force acting on mass 2, and this equals to 0. So the tension force equals to gravity force acting on the second object, which is mass 2 times g. Now let's look at mass 1. Again, Newton's second law says F net equals to mass 1 times acceleration. And here the acceleration is still 0. Now what is the net force? There is tension force that is pointing upward, and normal force that is also pointing upward, and gravity force is pointing downward, so minus gravity force. And this equals to 0. Now if we isolate for the normal force, we get gravity force minus the tension force. If we substitute the tension force that we found from mass 2 in this equation, we get normal force equals to gravity force on the first mass, which is mass 1 times g, minus tension force, which is mass 2 times g. So normal force is the difference in mass times the gravitational acceleration. So to answer the question, part A, if mass 2 is 2 kilograms, then normal force would be mass 1 is 10 minus 2 times gravitational acceleration, 9.8, which equals to 78.4. And in part B, if mass 2 is 5 kilograms, then the normal force would be 10 minus 5 times 9.8, which equals to 49 newtons. And that is the end of the video. If you like my videos, please like and subscribe, and I'll see you next week.